Good morning, class. We are looking at final exam review for trigonometry, trigonometric functions, identities, equations, applications, periodic functions, covering modules 1 to 4, all modules. We want to answer the following question. Part A, name the quadrant that contains the terminal point of the arc t equals 2, and you want to justify your answer. So let's go over a couple of things. So we are looking at a unit circle, a pair x comma y. This is 1, 0. The angle or arc is 0 here. Pi over 2 here. Pi. 3 pi over 2. Back to 0, 2 pi. X squared plus y squared equals 1. Y is represented by sine, x is represented by cosine, and tan of t is y over x, to refresh everyone's memory. Therefore, by definition, tan is y over x, which is also sine over cosine. Cotangent is x over y, or cosine over sine. Cosecant is 1 over y, or 1 over sine. Secant is 1 over x, or 1 over cosine. So, pi over 2 is about 1.57. Pi is about 3.14. 2 pi is 6.28 numerically, roughly. And so in quadrant 1, t has a value between 0 and roughly about 1.57. In quadrant 2, between 1.57 and 3.14. In the third quadrant, between 3.14 and 4.71, and finally in the fourth quadrant, roughly between 4.71 and 6.28. We are interested in t equals 2, and number 2 is between 1.57, 3.14, and therefore the answer becomes quadrant 2. We want to find the exact value of cosecant 11 pi over 2, and then we want to convert that also to degrees. So the reference arc is pi over 2, and 11 pi over 2, you can take out 2 pi or 4 pi or even multiples of pi. In this case, 8 pi over 2, we will take out. 8 pi over 2 results in 3 pi over 2 and 1 over sine. Cosecant is 1 over sine. We know sine of 3 pi over 2 to be negative 1. So 1 over negative 1 is negative 1. Again, bear in mind that we took off 2 pi, 4 pi, 6 pi, and so forth. In this case, 8 pi over 2 or 4 pi. Now we have this simple conversion. D over 180 is r over pi, and r is 11 pi over 2. The pi cancels out the pi. 180 times 11 halves. 180 divided by 2 is 90 times 11 is 990 degrees if we were to convert it from radians to degrees. So this would be an easy formula to remember. D over 180 is r over pi. If the length of an arc S is 50 inches in a circle with a radius of 6 inches, find angle theta this arc subtends. So let's go over a couple of formulas. So we have this arc length S, and S has the formula r theta. So let's stick with that first. In this case, S is given as 50, R is given as 6, theta is missing. We put that into this formula. Theta is S over R. and it gives us 25 thirds, and it's in radians. It's always in radians. To find the area of this sector, this area, it's 1/2 r squared theta. We have r equals 6, theta equals 25 thirds. So 3 times 2 is 6. We have one of those left. 6 times 25, 150. And units of area, since this is in inches, 150 inch squared. I have other formulas. Omega, the angular velocity is theta over t, or 2 pi times RPM. V is s over t, or omega. We are going to go over them in a moment. Each wheel of a car with a radius of 15 inches makes 3 revolutions per second. RPS, revolution, a complete revolution, is 2 pi radians. How fast is the car moving if we want to go with miles per hour? In other words, linear velocity. So again, S r theta, linear velocity v is total distance over total time. It's defined as S over t. Omega, it's the angular velocity, angle over time, theta over t, or 2 pi times RPM, the revolutions per minute. Sometimes it's RPS. In this case, it's RPS in our case, so times revolutions per second. And so V is S over T. S is R theta divided by T. So we can separate the theta over T. And as you know, this is omega by definition. So V equals R omega. So let's see what is given. R is 15 inches. Omega is 3 RPS because it's in seconds. Revolutions per second. Revolutions per second. We are interested in finding the linear velocity. And so first and foremost, omega is RPS times 2 pi. So 3 times 2 pi makes it 6 pi. It's in radians per second now. Radians per second. The V equals R omega. R is 15. Omega is 6 pi radians per second. So it's 90 pi inches per second. Now, all we have to do, it's a matter of converting inches per second to miles per hour. So inches per second, we want to go with miles per hour. Well, 1 foot is 12 inches. 1 mile is 5,280 feet. 1 minute is 60 seconds. 1 hour is 60 minutes. Let's put all of them together. Remember, we want to go from inches per second to miles per hour. This is the final answer we want. So we want everything to go away except miles in the numerator, hours in the denominator. So it is important as far as the unit conversion is concerned. For example, you can write 1 foot over 12 inches, or you can write 12 inches over 1 foot. It is 1. You can write 1 mile over 5,280 feet, or the reciprocal of that. The same thing here, the same thing here. How do you write them? You write them such that the final answer has miles over hours. So notice this will cancel this one. This will cancel this one. This second will cancel this second. And this minute will cancel this minute. Everything is canceled. Everything is canceled out except miles in the numerator and hours in the denominator. So let's do the math. We end up with 16.065 miles per hour. which means 90 pi times 60 or 3600, that can be done, divided by 12, also divided by 5280. All right, let's simplify sine squared plus cotangent squared plus cosine squared. Let's remind everybody about Pythagorean theorem and identities. Sine squared plus cosine squared is 1, 1 plus tan squared is secant squared, and 1 plus cotangent squared is cosecant squared. So basically, we can write these two next to each other and change it to a 1. And when we look at the last one, the answer must be cosecant squared theta. Cosine of pi over 6 times secant of 13 pi over 6. Well, we can take out 2 pi or 12 pi over 6. So we end up with pi over 6. And we know secant is 1 over cosine. Therefore, the answer must be 1. So 1 over cosine, meaning divide by cosine. Cotangent theta plus cotangent theta minus pi plus cotangent theta minus 2 pi. And I'm going to remind you about the fact that trigonometric functions, they are all periodic functions. And the period is 2 pi for all of them except tangent and cotangent. So sine, cosine, secant, cosecant, when you add 2 pi or in general 2n pi, you end up with the same result. In the case of a tangent and cotangent, is pi. So whether I add pi or subtract pi in the case of a cotangent makes no difference. This becomes cotangent theta, this becomes cotangent theta, and there are 3 of them, and that's the final answer. We want to find the amplitude, period, intercepts, and phase shift of the function and sketch the complete period for the function y equals -6 sine pi over 3x plus 4. And in general, it's in this form. The amplitude is the absolute value of this number. The period t is 2 pi over omega or b. This number sometimes is called b, this coefficient, sometimes it's called omega. In this case, is pi over 3. And 2 pi divided pi over 3 means number 6. So a complete period, it goes from 0 to 6 because there is no phase shift. If there's a phase shift, we move it accordingly. So if you recall, for sinusoidal functions, we go with 4 pieces, 4 arcs. So we're going to divide this by 4 equal pieces. And that results in 3 halves. And so that means we're going to go from 0 to 6, cutting it in 4 equal parts. The first one would be 0 to 3 halves. The next one would be 3 halves, 2. Now add 3 halves to 3 halves gives you 3, and continue. We end up with 0 to 3 halves. That's the first arc. 3 halves to 3. So remember, we are adding 3 halves to this. Adding 3 halves to this one, 3 to 9 halves. Finally, 9 halves to 6. And let's consider this for now without the plus 4, because the effect of plus 4 is going up and down. Because it's positive, it moves up. So if you ignore that and you want to graph this, basically, you can plug in those endpoints. For example, if I plug in 0 here, Sine of 0 is 0, minus 6 times 0 is 0. The next one is 3 halves or 1.5. If I put 3 halves here, I get pi over 2. 3 halves. 3 and 3 cancel each other. We have pi over 2. Sine of pi over 2 is positive 1 times negative 6. Makes it negative 6. If I put the next number 3 here, this one cancel each other. Sine of pi is 0 times minus 6 is 0, so on and so forth. So let's plug in all these endpoints. 0, 3 halves or 1.5, 3, 9 halves or 4.5, 6, and those are the pairs that we have. So let's plot those 3 pairs. 0, 0, 3, 0, 6, 0. So those are the x-intercepts for this function without the 4. The other 2 points, 1.5, negative 6, 4.5, positive 6. And the graph looks like this, again, without paying any attention to plus 4. Now, there is this vertical shift of a plus 4, which means the same thing moved up by 4 units. So one easy way, think about the x-axis has been shifted up 4 units. So just move these 4 units and draw the same thing. It's also called the midline, by the way. Y equals 4. Which means all you have to do, look at the y coordinates and add 4. This becomes 4. This becomes negative 2, 4, 6 and 4 is 10, 4. Look at this. So these are the new locations. So everything has been shifted up by 4 units. This may not be to scale. And this is one complete cycle. If we wanted to continue indefinitely on both sides, we could do that. This hasn't asked us to do, but in case. Now we are looking at a different function, y equals 2 cosine of 3x plus pi over 2. We want to graph this in the same manner. So let's first put it in a proper format. We notice there is a factor of 3 here. We take out. When you take out, this becomes x, this becomes pi over 2 divided by 3 or pi over 6. That's the first thing you need to do. So again, I want to take out a factor of 3 because I want to have a x here, just x. With that being the case, when I divide by 3, pi over 2 divided by 3 becomes pi over 6, which means the amplitude is the absolute value of 2. And the phase shift is minus pi over 6. And the period is 2 pi divided by 3. So this is the period, and this is the phase shift. Now, we're going to go with 4 cycles, 4 arcs, 4 pieces. We are going to divide this by 4. 2 pi over 3 divided by 4 becomes 2 pi over 12 or pi over 6. Pi over 6. Which means the length of each arc, for each arc covers about pi over 6. On a normal basis, we go from 0 to 2 pi over 3. Now 0 to 2 pi over 3, now it shifts by this much, so it goes to the left by this much. So minus pi over 6 to minus pi over 6 plus 2 pi over 3. I want to make sure everybody understands how we arrive at that. This normally means we're going to go from 0 to 2 pi over 3, and we cut them into 4 equal pieces. Each one we add pi over 6. Because there is a phase shift of minus pi over 6, this must move to the left by this much. Basically, you add whatever this number is to this, minus pi over 6, and to this one. So we're going to go from minus pi over 6. And if you add these two, by the way, the common denominator is 6. And so this becomes 4 pi over 6, and with the negative becomes 3 pi over 6 or pi over 2. Everybody's comfortable with fractions. So we are going to move that by this much. So minus pi over 6, when we add pi over 6 becomes 0. So minus pi over 6 to 0. The next one 0 to pi over 6. The next one pi over 6 to pi over 6 plus pi over 6 is pi over 3. And the last one is pi over 3 to pi over 2. So those are the location of each arc from 2. So let's start with minus pi over 6 and plug in here or here. It might be easier to calculate it. So if I replace the x with minus pi over 6, this becomes 0. 3 times that is 0. Cosine of 0 is positive 1 times 2 becomes positive 2. If I plug in the next one, this one doesn't matter. If I plug in 0, I get pi over 6. 3 times pi over 6 means pi over 2. Cosine of pi over 2 is 0. 2 times that, it is 0. The next one is pi over 6, and therefore it becomes 2 pi over 6 times 3. It's pi. Cosine of a pi, negative 1 times 2, negative 2. So you can see I calculated the first 3 for you. You can calculate the rest of them. And all you have to do, plot those pairs. Minus pi over 6, 2. 0, 0. Pi over 6 minus 2. And the rest of them, that's a complete period or cycle. And you can continue indefinitely on both sides if you want more than one cycle, and that's normally the case. We want to find the exact value of the expression and justify tan inverse of tan of negative 2 pi over 3. So first, let's have a quick discussion about inverse functions. When it comes to sine, when y is sine inverse of x, that means x is sine y. X is between negative 1 and 1, and y is between negative pi over 2 and pi over 2. F of f inverse of x is equal to x, as we remember from algebra. Therefore, when x is between negative pi over 2 and pi over 2, sine inverse of sine x becomes x. When x is between negative 1 and 1, sine of sine inverse of x is x. So we have to pay attention to the restriction. So again, in order for sine, all trigonometric functions, they are periodic, and none of them has an inverse unless you put a restriction on the domain. So the restriction we put on the domain of sine is from minus pi over 2 to pi over 2. We know its range is from negative 1 to 1. That's why we arrive at this. In the case of a tangent, it's very similar to that. The endpoints are not included. And the range, of course, is, remember the graph of tangent looking like almost y equals x cubed. The ranges are real numbers. Cosine, we have the same range for cosine, but the domain we restricted from 0 to pi because we want to include all values. And so in the case of a cosine, cosine inverse of cosine x equals x. If x is between 0 and pi, cosine of cosine inverse is equal to x if x is between -1 and 1. Now, a cosecant, which is 1 over sine, basically follows the sine. Of course, y can't be 0. Secant, which is 1 over cosine, basically follows cosine as far as the limitation. And of course, y can't be pi over 2. And cotangent is different also. Cotangent, in essence, is similar to cosine. So the restriction is from 0 to pi in the case of a cotangent also. So going back to this, because it's not in the interval of interest, if you look at the tangent, only in this case you can say it's x, so you can't say it's -2 pi over 3, so you have to figure out what this is. This is in quadrant 3, and it's the same as tan of pi over 3, so it's tan inverse of square root of 3, and that, of course, is now pi over 3. In other words, this is not where you want it to be if you look at this one, therefore you have to figure it out. Secant inverse of square root of 2. Let's represent it by alpha or beta or gamma, anything you want. By definition, secant alpha becomes square root of 2. And therefore, since we know about cosine, we're going to go with cosine. Cosine is 1 over secant. So cosine is 1 over square root of 2 or square root of 2 over 2. And we know this to be pi over 4. Again, so we use cosine to get to the answer because we are familiar with common arcs when it comes to sine and cosine. Cosine inverse of 1/2, again, let it be some angle or arc, let's say theta. By definition, cosine theta becomes 1/2. It is a common arc, theta becomes pi over 3. And remember, this is a unique answer. A tan of cosine inverse of square root of 3 over 2. And so let this be represented by an angle, for example, beta. By definition, cosine of beta is square root of 3 over 2, and that is also a common arc, which is pi over 6. Therefore, we are looking for tan of pi over 6, tan of pi over 6, and we know it to be square root of 3 over 3. Cosine inverse is 1.2, and this is undefined. The reason why, because 1.2 is larger than 1, and you can even set this, if you want, you can set this equal to x, let's say. So cosine x equals 1.2, and it has no solutions. It's undefined because cosine is between -1 and 1. We want to write a trigonometric expression for sine of tan inverse of u as an algebraic expression, and what it means if you let tan inverse of u is an angle, for example, alpha, beta, gamma, theta, then tan of theta is u, and you're interested in finding sine theta. That's the meaning of this. In essence, we are translating this into that. And there are a couple of different approaches. I want to go over that. We know that if tangent is u, cotangent is 1 over u, and we can find sine because we have the Pythagorean identity 1 plus cotangent squared is cosecant squared. So now cotangent is replaced by 1 over u, and we know that cosecant is 1 over sine. So cosecant squared is u squared plus 1 over u squared, and therefore sine squared is the reciprocal of that. Again, cosecant is 1 over sine, so sine squared is the reciprocal of that. And so we are interested in finding sine theta. It's the square root of that plus minus, and the reason we choose only plus, by the way, the u squared can come out as u, because Sine and tan have the same sign because they are both defined between negative pi over 2 and pi over 2. Let's look at it from a different point of view, which becomes a tad easier, and that would be tan is defined as opposite over adjacent. Tan theta is equal to u. Make it into a fraction of u over 1. If it is a fraction, so be it. If not, make it in a fraction such that the denominator is 1. So the opposite and adjacent. So the opposite is u. The adjacent is 1. And as you know, sine is the opposite over the hypotenuse. All you have to do, find this hypotenuse, which is the square root of 1 plus u squared according to Pythagorean theorem. Therefore, sine, which is opposite over the hypotenuse, becomes simply 1 over u over the square root of 1 plus u squared. As you can see, it's a lot faster than that, but these are different approaches. You can take the approach you're more comfortable. We want to look at trigonometric equations and identities, and I'm going to remind you of all of these formulas. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, so on and so forth. You've seen it. Sine to alpha is 2 sine alpha cosine alpha. Cosine to alpha is cosine squared minus sine squared, so on and so forth. And from there, we can get to sine squared alpha from these two, and also cosine squared alpha, and then the half angle formulas. So there are many formulas here which will help us move on to the next couple of questions. For example, if you are interested in using the half angle, no calculator, to find sine of 195, we know that 195 is 390 divided by 2, and 390 is 360 plus 30. So itself, 390 is a common arc. And so since we are solving for sine, so we are going to use this formula plus minus the square root of 1 minus cosine of alpha. That means cosine of 390 divided by 2. And as you know, 390 is 360 plus 30, as I mentioned. So this is the same as cosine of 30. And why are we switching from plus minus to minus? Because 195 degrees is larger than 180. In quadrant 3, sine is negative. So that's why we switched from plus. First, we put the plus minus, then we figure out what it is. Cosine of 30 is square root of 3 over 2. So we can multiply this one by 2 over 2. The denominator becomes 4 and comes out. And the numerator becomes square root of 2 minus square root of 3. This is the precise answer. We want to find cosine of 15 degrees. We know it's cosine of 30 over 2. So we use this formula, plus minus the square root of 1 plus cosine of 30 degrees over 2. We know cosine of 30 to be square root of 3 over 2, and we know 15 degrees is in the first quadrant, so plus minus changes to positive only. Again, 15 degrees in quadrant 1, everything is positive. Again, we're going to multiply by 2 over 2. The bottom becomes 4 and comes out as 2. This one becomes 2, this one goes away, 2 plus square root of 3 under the radical. And again, this is the precise answer. You've seen this before. You can try this as cosine of 45 minus 30 and use the cosine of difference to come up with the answer. In this case, we want to prove the identity cosine of pi over 2 plus x equals minus sine x. We start normally from the more complicated side, and reminding everybody that sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and the rest of it. Therefore, in this case, we're going to use cosine of alpha plus beta, which is cosine alpha cosine pi over 2 from the left. This is the left-hand side. Cosine of pi over 2 cosine x minus sine alpha sine pi over 2 sine x. As you know, cosine of pi over 2 is 0 and sine of pi over 2 is 1. Therefore, this goes to 0. This becomes negative sine x, and that is the proof. For this one, again, we start with the more complicated side, which is the left-hand side. And as you know, a tangent is sine over cosine, secant is 1 over cosine. And so all you have to do multiply by cosine over cosine, and you get sine theta over 1, or simply sine theta. It's pretty easy to prove that. We want to find the exact value of the expression 2 sine pi over 8 cosine pi over 8, and we remember sine of 2 alpha is 2 sine alpha cosine alpha. So this is sine of 2 alpha, sine of 2 times pi over 8. As you know, 2 times pi over 8 is pi over 4. Sine of that is square root of 2 over 2. Use a similar formula. 2 sine 45 cosine 45 is sine of 2 times 45, which is sine of 90, which is 1. Cosine of 7 pi over 12. One way is to cut it into two pieces, 3 pi over 12 and 4 pi over 12 using cosine of alpha plus beta. And 3 pi over 12 is pi over 4, a common arc. 4 pi over 12 is pi over 3, also a common arc. So according to cosine of alpha plus beta, this would be cosine of pi over 4 cosine of pi over 3 minus sine of pi over 4 sine of pi over 3. And cosine of pi over 4 and sine of pi over 4, both of them are square root of 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. So as you can see, the denominator in both cases is 4. This is square root of 2 minus square root of 6. And that's the final answer here. We want to find the exact answer. This is cosine of pi over 2 minus 5 pi over 2 according to the formula for cosine. Cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. I'm reminding you of that. So pi over 2 minus 5 pi over 2 is negative 4 pi over 2, or negative pi over 3. Cosine of negative pi over 3 is the same as cosine of pi over 3, which is 1/2. Remember, cosine is an even function. All trigonometric functions are odd except cosine, and with cosine goes secant. So cosine and secant are even functions. In other words, cosine of minus theta is cosine of theta. All right, let's look at sine of 165 degrees. We can write it as sine of 120 plus 45 degrees, and we use sine of alpha plus beta in this case. So sine of 120, cosine of 45, plus cosine of 120, sine of 45. Now the reference arc for 120 is 180 minus 120, or 60 degrees. Sine of 60 degrees and sine of 120 degrees are the same. It's square root of 3 over 2, because in the second quadrant sine is positive, but cosine of 120 degrees is the same as negative cosine of 60 degrees, or negative 1/2. Therefore, we have square root of 3 over 2 times square root of 2 over 2 plus negative 1/2 times square root of 2 over 2. It's important. I kept the plus sign, but I put the negative here so it will be clear. This is negative and why this is the case. So as you can see, the denominator is 4. This gives you square root of 6 minus square root of 2, clearly. And that's the exact answer. That's the exact answer. We want to establish the identity, and we start with the more complicated side. In this case is the left side, by changing the tangent to sine over cosine. So left-hand side, LHS, short for left-hand side. And so now we are going to take a common denominator, which is the product of cosine theta and 1 plus sine theta. Then sine theta times 1 plus sine theta gives us sine theta plus sine square theta, plus cosine times cosine is cosine square theta. In other words, take a common denominator, add them up. I'm assuming everybody can add them up. These two add up to 1. So we are looking at sine theta plus 1, and sine theta plus 1 is identical to 1 plus sine theta. We can cancel them. The numerator changes to 1, and 1 over cosine is the same as secant. Let's look at this example. Again, we start with the more complicated side, namely the left-hand side, and we take a common denominator of sine times cosine. So when we put them together, sine 3 theta times cosine theta minus cosine 3 theta times sine theta would become the new numerator. We are adding up the two fractions. We remember sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So sine alpha cosine beta minus cosine alpha sine beta. That means the top is the sine of alpha minus beta, sine of 3 theta minus theta, on the one hand. On the other hand, if we had a 2 here, would be sine 2 theta. If we had a 2. Since we don't, it's half of that. According to this, it's half of that. So the top is sine of 3 theta minus theta. And this is half of 2 sine theta cosine theta. We're going to change this to sine 2 theta, and the denominator half of sine 2 theta. These two cancel each other. One over 1/2 is positive 2. Let's solve this equation. Cosine squared minus sine squared plus sine x equals 0, where x is between 0 and 2 pi. And anytime we have cosine squared and sine squared in an equation, we have to go with one of them. And we know Pythagorean identities. Sine squared plus cosine squared is 1, 1 plus tan squared is secant squared, 1 plus cotangent squared is cosecant squared. So which one do we use? And this is what's going to happen. You look at what you have here that you can't change. I cannot change the sign, but I can change this one or this one. I can say cosine squared is 1 minus sine squared. Or I can say sine squared is 1 minus cosine squared. I can do either one. Since I can't change this, I'm going to keep this and I'm going to change the cosine squared to 1 minus sine squared. So everything will depend on sine. So this is 1 minus 2 sine squared plus sine x. And since I want to do factoring, I'm going to either multiply everything by negative or take everything to the right. It doesn't matter. So this becomes 2 sine squared, this becomes minus, this becomes minus. And so now it gives me a chance to factor. 2 is a prime number and it's easy to factor it. You can just put sine x and then 2 sine x. And when you do the factoring, remember, this is clearly 2u1, negative 1. So one of them is 1, one of them is negative 1. Put them in a proper place such that the middle term is minus sine x. As you see, this is positive sine x. This is negative 2 sine x. They do add up to the middle term. Therefore, you said this one equal to 0 or this one equal to 0. And this one gives you sine x equals negative 1/2. This one gives you sine x equals 1. Now, when sine x is negative 1/2, remember in the case of a positive 1/2, the reference arc, I want to make sure everybody understands how that works. For sine x equals 1/2, reference arc is pi over 6, reference arc. So same thing here, the reference arc is pi over 6, but it's negative. Where is sine negative 1/2? It's in the third and fourth quadrant because sine is positive in the first and second. So in the third quadrant, we add pi over 6 to pi. And in the fourth quadrant, we subtract it from 2 pi. So adding pi over 6 to pi gives us 7 pi over 6. Subtracting it from 2 pi gives us 11 pi over 6. And again, I write that. I want to make sure you understand how easy you can come up with this. So pi plus pi over 6, or this one, remember this is your reference arc, and 2 pi minus pi over 6. As far as sine x being negative 1, there's only one answer, and that is pi over 2. Therefore, we have 3 answers.